Welcome to this exercise 11C, Oxford IB AASL, geometry and trigonometry. So question 1, find the value of theta. Let's look at part A. If you look at theta, theta has an opposite side directly to it, and it also has the hypotenuse. So if we use the acronym SOHCAHTOA, the one that has opposite and hypotenuse is sine. That means if we do the sine of the angle theta, will be given as opposite divided by hypotenuse 27. If you want to get theta, you're going to do the sine inverse of the fraction, 27 over 19 over 27. You are going to proceed and you're going to use your GDC to do this. Let me share the GDC. Clear. So we are going to do sine inverse. Sine inverse is second sine. Then write the fraction 19 divided by 27. Make sure if you want your calculator in degree mode, you come to mode and then move down until here when it's written radian in degree, put it in degree mode. If you go back, you'll see our answer is 44.72. So you have to leave your answer to 3 significant figures. So we'll have our answer as 44.7 degrees. 44.7 degrees. So now I'm going to put draw. So 44.7 degrees is the answer for A. Then for B, you will notice that we have this angle theta here. It has an opposite side directly above, directly to it, and then we have an adjacent side. An acronym with opposite and adjacent is tan. So if you do the tan of the angle theta, should be opposite divided by adjacent. So if you want to get theta, you have to do the inverse of tan on both sides. So tan inverse 33 over 56. I can share the GDC to know how you can insert that in the GDC. So we'll come to second tan 33 divided by over 56. Some people might use the fraction, which is alpha link. There's a fraction here, or alpha y equals, there's also a fraction there. So if you put this on, you'll get 30.5102371. With 3 significant figures, that is 30.5 as your answer. So you're going to write 30.5. 30.5, draw. Theta is 30.5 degrees. Okay, part C. Theta has 90 degrees is here, so it has an opposite side and it has an adjacent side this way. So which one has opposite and adjacent? That is tan. So if we do the tan of that angle, it should be given by opposite over adjacent, 12 over 5. If you want to get theta, you do tan inverse of that fraction. Tan inverse of 12 over 5. I don't have written 15. I'm going to erase this and write over 5. So 12 over 5. Since this one is not a fraction from a special triangle, that's the reason why you're going to use your GDC to get those values. So we're going to do tan inverse. So that is second tan 12 divided by 5. So you will get your answer 67.4. 67.423 significant figures. You're going to write your answer as that. So for number C, that is the answer. 7.4 degrees. Okay, let me gather some more space. So it looks like, okay, so to part D, I look at part D, look at the angle theta, and we look at where 90 is. 90 is here. So this angle has an hypotenuse and it has an adjacent. So an acronym for that has adjacent and hypotenuse is cos. Cos of that angle should be given by adjacent divided by hypotenuse. For us to get the angle theta, you have to do cos inverse of the fraction. It's inverse 11 over 20. So that you'll get your answer as theta is equals to cos inverse 11 over 20. I can share my GDC for us to input that. So cos inverse is second cos. So second cos 11 divided by 20. 56.6. 3 to 3 significant figures is 56.6. 56.6 degrees. So that's for number one, just finding the angle theta. ABCD. Let's look at number two. Let me make space for number two. What we say is find the value of x. I want to know how on this side. All right, so let's look at A. Part A says that this x, this is a right angle triangle, so we are allowed to use the ratios. So this x is an adjacent side to this angle, and we also have hypotenuse. So our ratio that relates adjacent and hypotenuse is cos, so k. So we can say cos 22 degrees is given by x over 27. So how do you get x? X will be given by 27 plus 22 degrees. All right, so use your GDC to do 27 times cos 22. As you can see on the screen, we have 27 multiplied by cosine of 22. Close your bracket. See, you get 25.033. To three significant figures, that is 25.0. So we're going to write 25.0 as our answer. So this is 25.0. No units given, so we can't include any units. Part B, we have x here, but we look at this angle, this is a right angle triangle. So this is gonna be adjacent to that and opposite to that. It is tan that has opposite of adjacent. So we can simply do tan 46 degrees is equal to opposite divided by adjacent, which is x. And now we can confidently include our Can make X the subject, can do a reciprocal. So let me delete this. So for you to get X, you can do reciprocal on both sides. The left-hand side, it will be 1 over tan 46 degrees is equals to reciprocal X over 44. So for you to get X, you're multiplying 44 this side. So it will be 44 divided by tan 46 degrees. So 44 divided by tan 46 degrees, you can use your GDC to get that. I will write 44 divided by tan 46. So we write tan 46, then close your bracket. Remember, it is still in degree mode. We are getting 42.49 to three significant figures is 42.5. 42.5 degrees. X is 42.5 not degrees because it's length. 42.5, no units, so we can just leave it at that. I want to see if I can make space by cutting this. Let's cut number 2, number 3. And let me use this opportunity to upload a screenshot by screenshot. If I erase, you can always go back and watch what you have done. So you have just cleared number 2. So we are moving to number 3. So number 3, I'm going to put number 3 here by virtue of screenshots. So I'm going to open it on the other side. So make sure you are well versed with the GDC and you can use it comfortably. Since I lost the document. Okay, so because I had cut, I'm just going to Control Z so that it can return me where I was. There you go. All right. Okay, look at number, that is B. So I'm going to clear so that we do the rest in that space. Now let's look at C. X is a side, and then we have 90 degrees, so it's right angle triangle. This angle has an adjacent side called X and opposite side called 7. So which ratios, which acronym goes with that? You'd realize it is tan. So tan of an angle is opposite of adjacent. So we can do tan of 46 degrees is equals to opposite over adjacent. So for you to get X, you can do the reciprocal we did and realize that it is 7 divided by tan 46 degrees. So 7 divided by tan 46 degrees. So use your calculator. The GDC and do 7 divided by tan 46 degrees. 6.759 to 3 significant figure is 6.76. So 6.76 is our answer at that point. So we're going to write 6.76 here as our x value. And then part D, the last one, the 90 degrees is here. Be careful on where it is. Then it has the hypotenuse and then it has the opposite. So opposite hypotenuse, that should be sine, which is so opposite hypotenuse. So if we do the sine of 43, it will be given by opposite side divided by hypotenuse, where your x should be 22 multiplied by sine of 43. So you're going to use a GDC to input 22 multiplied by sine of 43. So we're going to write 22 multiplied by sine of 43. 15.00. The three significant figure is 15.0. So you're going to have 15.00 answer. On this other side, 15.0. We are done with number 2. We're going to number 3. Allow me to delete this so that I get space, or let me move down and see if there's space. I'll have to delete. I think in our next video, I'll be putting screenshot one by one so that we have enough space for this. Okay, so that is number 2. Number 3, find the value of h and the value of a. And you know a has a cap on top, that means it is an angle. All right, so if you look at the diagram, I'll start with h because I already have this angle here. So h is the opposite of the angle, and also this angle has a side which is adjacent to it. So opposite and adjacent has a tan, takes the tan acronym. So we can do tan of 25 degrees will be given by opposite over adjacent. So h is equals to 12 multiplied by tan of 25 degrees. So because this one is being multiplied that side. So you're going to use your GDC to do that because this is not a special triangle that you can easily see the answer. So we're going to do 12 multiplied by tan of the angle there, which is tan 25. Tan 25, closing bracket, enter, 5.5956. You can write answer to a very significant figure, but for the sake of accuracy, you can choose to write all those answers. But three significant figures, for the sake of accuracy, for you to do the next question, because it depends on it, you can use the whole figure, or you can write the three significant figures, which is 5.60. And then this is number 3. Then for you to calculate A is here. It has an adjacent side and it also has an opposite side. So you're going to use tan also. So you'll say tan of A degrees is given by tan of angle A is given by opposite divided by percent. Allow me to put your computer to charge before it goes off during the lesson. So you might want to pause the video and do that before completing it. Now h now will be given by what we got up there. But if you want to do be accurate, you would want to put the exact value of h. So tan A should be given by, remember h was 12 multiplied by tan 25 degrees divided by 10. So if you want to get A, you have to do 10 inverse of the writings on the right side. So let's see how much is angle A. So angle A is tan inverse of 12 times tan 25 over 10. So you're going to use your GDC for that. I would share the GDC. So we have to do tan inverse, which is second tan. And then let's put some fractions. The numerator has 12 multiplied by tan 25. Close your bracket. And then in the denominator, we will have 10. So you'll have to close your overall bracket. Then enter, you'll have your A as 29.23 to three significant figures is 29.2. I'm going to share the other side, 29.2. So I'll move up a little bit and this will be 29.2 degrees. So that's for number 3. Let's look at number 4. Number 4 says find the value of P and the value of Q. So number 4, same scenarios up there. We can start with Q because I see 30 degrees as an opposite side directly to it, and then we have the whole of adjacent side because it's 90 at this point. So all this length from here to here is adjacent to the 30 degrees. So adjacent and opposite, that is tan. So you can say tan 30 degrees is given by opposite divided by adjacent. Q divided by 55. So if you want to get Q, you'll have to multiply tan 30 with 55. So you can either use your GDC or by hand, using the special triangle. 30 degrees is here. This is equal to 3 and then this is 2. So we'll have 55 multiplied by tan 30, which is opposite is 1. So which is 1 divided by square root of 3. You need to write that as an exact answer, 1 divided by square root of 3, so that your answer is 55 over 3. You can rationalize 55 times root 3 divided by 3. Or else you can use your GDC. If that was the exact answer for Q, but you can use your GDC to get the answer in keeping in mind the accuracies. So we're going to say that Q is given by 55 times tan 30. So you're going to write 55. Then you're going to write times tan 30. 31.754. So to three significant figures, 31.8. So you're going to write 31.8 as Q also. This answer is also right. 31.8. Since it's a side, it's a length. And how do we get P? Now we will need to calculate what distance is it from here to here, where the 50 degrees is, so that we subtract from 55. And how do we do that? We can use the Q we have. and we can say let this distance be x. So if you have opposite of 50 and adjacent, we can say the tangent of 50 will be given by opposite of adjacent. And we remember Q was, the exact value of Q was 55 times tan 30 degrees. And then we have X. So I know this is, if I use these two types of X's are confusing, let me use a dot for my product. Okay, so how do we get X? X will be given by 55 times tan 30 divided by tan 50. All right, so we'll have the answer to that, and then if we get that, P will be given by 55 minus X. So the answer we will get, we'll directly subtract it using our GDC so that we are accurate. So I'm going to share the GDC. And let's do the subtraction, the required computation. So we are saying that to get X, you do 55 multiplied by tan 30 divided by tan 50. No. So we share the calculator, and then we said so X is equals to 55 times tan 30 divided by tan 50. Division will come first before multiplication, and it will just be the same thing. It will give you the same answer. Let's see if there will be a difference if we put brackets. So let's start with 55 multiplied by tan 30 first, because that was our value for Q. And then you divide this by tan 50. Yeah, these are different. So make sure you follow the board mass. So 26.64499,189. So that is the value of X. So we'll say the value of Q will be 55, subtract this answer we have. So you'll go up and then you select it, and then you have the answer. So you get 28.355, which is 28.423 significant figures. So we're going to write 28.4 as our answer. I'm going to share the other side. For 28, P is 28.4. Let me move up. This is what I wrote, 28.4 with the P. That's number 4. Let's move to number 5. If you are still having a challenge in doing it, go back and watch the video slowly. And I hope that will and you improve. So that is number 4 now. Number 5. We are calculating the value of X. There's no labeled X there, so we will not calculate that. They have not labeled any X. But you can just find the missing length. You can have your 90 degrees here because this is an isosceles triangle. Two sides and two angles are the same. So if this is 90, this one will be 7 and this one will be 7. So let's say X was the hypotenuse. You're going to use the cos, because this angle has an adjacent and you're looking for hypotenuse. So you would say cos 20 degrees will be given by adjacent divided by hypotenuse O. So O is equals to 7 divided by cos 20 degrees. So let's see what that gives us. Math is amazing. Should be doing math every time you get an opportunity. So 7 divided by cos 20. 7.49449. So to three significant figures is 7.45. 7.45. That will be the value for x. Yeah, for a missing value, we don't know where x. But if they made the hypotenuse, then 7.45 is the answer. Let's move to number 6. Number 6 is find the height of a cone of base radius 6 centimeters and theta is 30. So this is the height. This is 90 degrees. So we have a right angle triangle. This angle has an opposite side, and we are looking for the height, which is the adjacent of that angle. So opposite adjacent, so that is tan. So tan theta, tan 30 degrees is equal to opposite over adjacent h. So h for this case will be 6 divided by tan 30. It is 6 divided by tan 30 because previously we had this, and then we said you do the reciprocal of the right hand side and left hand side, and then you cross multiply. 6 divided by tan 30, it's a paper 1. You're going to write your answer in form of radicals. You have done this before. You turn tan 30 to according to what the special triangle says, and then you are going to use that. I want to share the GDC so that you can do 6 divided by tan 30. 6 divided by tan 30. 10.39 to 3 significant figure is 10.3, 10.4. So your answer there is 10.4. Because the units are in centimeters, centimeters. Let's look at number 7. So number 7, let me share that side. So number 7 says the diagram below shows a rectangular based right angled pyramid ABC. So we'll have A, B, C, D, and T. AD is 20, DC is, CD is 15, TN is 30 centimeters. So find the volume of the pyramid. So exercise 11B, in exercise 11B, we learned how to calculate the volume of a pyramid, and the formula was given by a third base area multiplied by perpendicular height. So our base area will be the area of the base, which is a rectangle, 20 times 15, length times width, then times height, which is 30. If you cancel this one out, we'll give you an answer of approximately 3,000, an exact answer of 3,000 square centimeters. But B is asking you to find TC. Look at TC. TC is an edge, a slanting edge. And for us to calculate TC, we will need to draw a perpendicular line from T to M, like that. And then otherwise, if you don't want to use TM, you can use TN, which is 30 centimeters, and NC. Let's look at how that looks like in a diagram. So I'll draw this triangle. So this is T, this is N, and this is C. So we want TC, this is 30 centimeters. We want TC, but we can really get NC. How do we get NC? NC is the, what do we call? The diagonal of that base, which is rectangular in nature, and it is 90 degrees. And let me draw well. So let me draw the base very well for us to find NC or AC. So we'll have the, let me just do this, and then the hypotenuse. So this will be A, this will be C, this is 90 degrees, then this is D. We know this is 20 centimeters, and then this is 15 centimeters. So we can really get AC, and N is perpendicular, so it is directly above the base, and at the middle of the base. So this is N. So if we get AC, we can be able to do half it for us to get NC. How do you do that? Use Pythagoras theorem that AC will be given by square root of 20 squared plus 15 squared. I started here, AC squared is equals to AD squared plus CD squared. So if you only want AC, you're going to do square root of the square of the two lengths. So you can use your GDC and you will get your answer here as 25. So AC is 25 centimeters. So 25 centimeters. So that means our NC will be half that length, which is 25 over 2 centimeters. So we have NC for this triangle. Remember, it is 90 degrees at N. So this is 25 over 2 centimeters. This is 30 centimeters. So it is easier for us to get TC by using Pythagoras theorem, which will be the square root of 30 squared plus 25 over 2 squared. Use your GDC, 30 squared plus 25 over 2 squared. And then if you do the square root of that, that should give you an answer of 32.5 centimeters. So TC, that is the answer for part B. For TC, allow me to delete or erase these workings so that I can be able to calculate more. Let me write the answer for this so that, so TC is 32.5 centimeters. Okay, but C asks you to find the angle. Find the angle between the edge TC and the base ABCD. Edge TC and ABCD. So we say the angle between an edge and the base is the same as this angle. It's the same as this angle. This is the edge TC, and then you're going to have a projection of it by drawing a perpendicular line. So the projection of this line is this line, CN to NC, so which is 90 at this point. So the angle between an edge and a surface is the angle between the edge and its projection on the surface. So the projection of TC is NC. It's like a shadow. If you project a sunlight directly above TC, it will cast a shadow on the base as NC. But we have NC already. NC was 25 over 2. It's half that whole length, which was 25. And then TN is 30 degrees. And then we also have TC as 32.5 centimeters. TC might have been influenced by some errors. So I'm going to use exact length. Calculate this length, what I call theta, angle C. So the angle between TC and the base is angle C. How do you calculate angle C? We can use tan because I'm seeing tan angle C is equals to opposite 30 divided by adjacent 25 over 2. So that our angle C will be tan inverse of 30 divided by 25 divided by 2. So use your calculator to do tan inverse 30 divided by 25 divided by 2, and you are going to get your answer as 67.4 degrees. That is the angle between the edge and the base. So moving on to part D, they are saying that the M is the midpoint of DC. M is the midpoint of DC. And then they're asking you to find TM. So the best thing to do while doing this kind of questions is to draw them out and see how I can represent. So find TM. So the line I had drawn previously. So you can draw that triangle down. So you can have TC here and TD here. And then remember this is 15 centimeters. M is here. So they want TM. Because this is the midpoint, this should be half of the whole length. This one should be half of the whole length. Remember the value of TC, 32.5 centimeters. So, and we want length TM. So we also have angle C. So we can say tan, not tan, we will use adjacent and hypotenuse, so cos. Cos angle C will be given by MC divided by TC. So remember angle C, we got it previously, which was the angle between TC and ABCD. So cos 67.4 degrees, cos 67.4 degrees is the same as MC, which is 15 divided by 2. Actually, we don't need that because we are calculating TM. So I was right when I said tan because we want the opposite side. Sorry for that. So we are going to calculate TM by using the tan of C, which would be equal to TM opposite divided by adjacent MC. So this will be tan C. C is 67.4 degrees. TM, we are looking for it, and then MC is 15 over 2. You can also use sine because you need opposite and then you have the hypotenuse. So if you want TM, you're going to multiply and 67.4 by 14 by 15 over 2. Okay. Then 15 over 2 times tan 67.4 should give you a value of 71, not 71, 31.6 centimeter. Some people can use Pythagoras theorem, that is the other way around, because this is 90 degrees, you're going to say this one squared minus hypotenuse squared minus adjacent squared for you to get that answer. That is part D. Part E asks you to find the angle between the face TCD and the base ABCD, which is the same as angle TMN. Okay, so I'm going to draw that triangle, but I am going to draw from T to N, then from T to M, and then we join these two. Remember, this is 90 degrees from T to N. This is 30. This NM is half of AD. If you can check, it's the same length. So this should be 10. And we have also gotten TM as 31.6. And they're asking for this angle M. So we can use tan M will be given by opposite 30 divided by adjacent 10. So M should be tan inverse 3. 30 over 10 is 3. So 10 inverse 3 is 71.6 degrees. Just confirm that using your calculator. In three significant figures, it will give you that answer. All right, so lastly, we have question 8. Question 8 talks about the Great Pyramid of Giza, which is square-based. So that is a very important point there. It is square-based, whose pyramid has the side length of 230.4 meters and the vertical height is 146.5. So the Great Pyramid is represented in the diagram below as A, B, C, D, and E. The vertex E, this vertex E, is directly above the center O of the base. M is the midpoint of BC, which is here, and calculate the volume of the pyramid. Once more, volume will be given by a third of base area multiplied by height, which is a third. Base area is a square, so we are squaring the length multiplied by perpendicular height, which is 146. So use your calculator to do that. You can share the GDC. So we are doing 1/3. Multiplied by 230.4 squared, multiplied by perpendicular height, which is 146.5. All right. We have 2,592,276.48 cubic meters. So you can put your answer as three significant figure, but also it is well represented if it is in standard form. So those 2,580 something from your calculator, you will put them in standard form as 2.59 times 10 raised to 6 cubic meter. Okay. So 2.59 times 10 raised to 6 cubic meter, confirm that that is your answer for the volume. Then the second question is find EM. EM is that slant height for that triangle. We have done this in the previous question. So for you to get that, I'm going to draw this triangle that will help us get that. I'm going to draw EO, which is 146.5. I'm also going to draw OM. OM is half AB, which is 230.4. If you divide by 2, you get 115.2. So we will calculate EM using Pythagoras theorem since this is 90. So EM is square root of the other two sides squared. So if you use your calculator, I believe you are able to get an answer like 186.3686. So to the significant figure, that is just 186 meters. 186 meters. Then show that the angle between EM and the base of the pyramid is 52 degrees correct to two significant figures. The angle between EM and the base. The angle between EM and the base will be the angle between the line of the line segment of the edge and its projection. Remember that if you draw EM here, the projection on the base will be the OM, because if you draw a perpendicular directly from it falls there, so where they meet is OM. So we are supposed to look for this angle M. And we have the diagram here. So angle M will be given by, we'll use tan. M degrees is equal to opposite divided by what? Divided by adjacent. So that M will be tan inverse 146.5 divided by 15.2. So if you use the calculator and do this, because you have done before how to write angles, you'll get your answer as 52 degrees. So they have said to do significant figures, so you get 51.8, so which will turn out to be 52 degrees. Right, find the total surface area of the pyramid. So what is the total surface area? Total surface area is given by the base area plus area of triangles. We did this in exercise 11B, and we said that this is the same as saying base squared plus 2x times the height, perpendicular height of one triangle. We call it L or H, no problem. So X is the side length of the square you have, because this is a square. So that you will have 30.4 squared plus twice times to 30.4, then times, that is, this one is the base, X is the base of, let's say, for example, you are considering triangle BCE. So the base is BC, then multiplied by the height EM. And I believe we calculated EM and got 186. So insert this one in the calculator, and let me be consistent in writing my X. So let me use X as that and then X as that, so that it is differentiated from multiplication. Insert this in the calculator and you're going to get your answers 138,792.96, which is similar to 1.39 times 10 raised to 4 square meters. So that's for the surface area. Then find the angle between an edge and the base. So we're going to choose any edge and the base. So an edge is a line. For example, you can choose line EC because we have used it before, and you can find the angle between line EC and the base, or edge EC and the base. So that will actually be angle C. So how do we find angle C? So angle C can be given by angle C. So we're going to use a trigonometric ratio. So we're going to use tan C. Tan angle C will be given by opposite, which is OE, divided by adjacent, which is OC. OE is 146.5. 146.5, and then OC, I believe we calculated OC somewhere, but if we didn't calculate OC, we can find it. It is the hypotenuse of the square below in form of a triangle. So I'm going to draw that triangle here. So this triangle ACE. So since this is a square, both sides are equal to 30.4, 30.4. So for you to calculate AC, you have to, let me do it here. So AC will be given by square root of those sides squared. So if you use your calculator to do 230.4 squared, plus 230.4 squared, and then square root to get your answer out. 325 325.8348,048. But because we want OC and O is in the middle of the midpoint of AC, we're going to divide that by 2. And our OC will be around 162.9174024. I'm writing the whole answer so that we can be accurate. So if you want to get C degrees, or the angle C, you have to do tan inverse of your fraction on the right hand side, 162.9174024. So you're going to divide that, and you're going to do tan inverse of that using a GDC, and you will get your answer as 41.96 to some other number. So to 3 significant figures, that should be 42.0 degrees. So that's it for exercise 11C. Kindly reach out for feedback and maybe something you have not understood. Thank you.